Okay, let's give you guys some practice. So we've seen this list before. We've seen this list before. Decide which one you would use in order to work out the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, we should be using this one here because this is of the form, is of the same form here, to the power of n to the power of n. But when you do this, you can't reason like this. You can't reason like this. So you could argue that, well, as n tends to infinity, you could reason like this, but this would be the wrong way of doing it. So you can imagine this as being one bubble, this as being another bubble. You could argue that as n tends to infinity, this 2 here is going to be negligible. So it's just going to, it boils down to the top bubble being just n. And then as n tends to infinity, there's nothing around here, so it's just going to be n. So you could argue that this is going to be, well, n over n is going to be 1, and then 1 as n, 1 to the power of n. Then you could argue that, oh, 1 to the power of n as n tends to infinity is going to go to 1, because 1 times 1 to the power of 3 is 1 times 1 times 1, and so on. It will remain as 1. So you could argue that, but it's not right, because you see, down here you could do this. Down here you could argue that as n tends to infinity, the top bubble will be, well, you're adding a 5, which is negligible. It's going to be so small as n becomes very, very big. So it's just going to be 3n. And then at the bottom bubble here, you see this works down here. This works because, you see, here you've got one thing, you've got a bubble and a bubble. The bubble is changing, but then as n is moving, you're acting on, you see the n is moving about, and yet what's inside here is moving about, and then you're using what's moving about to act on what's been moving about, if you know what I mean. Here, you've just got one bubble over another bubble. There's nothing acting on what's being moved here. You see, up here, if you have another end here, or 2n, or 2 to the power of whatever here, then this thing is moving about, and this thing here is moving about also, and it's acting on what's being moved. If you have something like this, then it's okay, because this is moving about, and yes, you're acting on what's being moved, but what you're acting has nothing to do with n. Up here, you're acting on this thing here, and n is moving about. Here, the square root is not moving about. It's independent of n. So you can't use. So when it comes to this, you can't use the argument where, oh, as n gets very, very big, that too is going to be negligible. So just think of, you can't argue like this, because here you've got this n acting on top of things that are moving about. If you have a square root, it's okay here, because the square root is fixed. Well, anyway, I hope you can follow that. So to really do this, so to find the limit of this, oh, now we're going to use our new notation, because, well, rather than having to write lim as n tends to infinity and so on, this would be a quicker way of doing it. Just rewrite this whole thing as this. So now this is the same as, well, we want to make use of this. So we want to split this fraction up into two separate fractions. So this bit here, split it up as this, and then split it up as this, and then now, hang on, bear with me. And now this is of the same form as this, because this one here is this one, and then you've got something that doesn't change. You've got something that doesn't change. You've got something that's fixed. This negative 2 here is fixed, and then you've got your n here. You've got your n here to the power of n to the power of n. So this is of this form here. And then now, if you look at this x here, then it will be e to the power of x. So it will be e to the power of x. So the limit here will be this. Okay. So next question. So similar to the previous one, decide which one you would use in order to find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, you should be using this one here. This is of the same form as this. So if you look at it, well, this is going to be 0. And if you think about it, what's happening up here would be 83 times 83 times 83 times 83 times 83 times 83 and so on. What's happening down here? Well, let's say as n tends let's say n is 100, as n tends to infinity, let's just say it's 100. It's going to be 1 times 2 times 3 times 4 times 5 and so on. There will come a point when you will reach 83 and then times 83 over 84 and so on. The point here is that if you look at here, you've got the numerator divided by the denominator, but beyond this point here, you've got 84 here times 85 times 86. Beyond this point here, the denominator will get much bigger than 83, because the numerator at the top is just going to be 83 all the time, 83 all the time. But then beyond this level, it's going to be 84, 85, 86, eventually all the way to infinity. So eventually the denominator will be massive. The numerator is just going to be 83 times 83, 83, 83 all the time. This, well, you should have a gut instinct that this would be much bigger than this as n tends to infinity. So you should just know that it heads towards 0. Okay, so the answer here is going to be 0.